Hey, it's Mr. Allred here, and we're going to talk about our second method of solving quadratic equations. The first method was factoring, but we know factoring doesn't always work. So our second method will be the quadratic formula. And the quadratic formula also needs to have everything on one side of the equation so that it's equal to 0. So we need it to be in the form ax squared plus bx plus c equals 0. And if this is the case, we can take the coefficients there, a, b, c, and we can plug them into a very specific formula that will calculate the solutions. That formula is x equals, and there's a big fraction. The numerator is negative b plus or minus the square root of b squared minus 4ac, and then all of that is over 2a. Couple things there. All of that information, b squared minus 4ac, is under the square root. And this plus or minus in the middle, we'll look at it, but it's what allows us to have two answers. So it's one formula, but in one version of the formula you could add parts together, and in the other version you could subtract. And we're going to see it used. But the quadratic formula will solve any quadratic. Now you might have to make a few adjustments depending on what we mean by any. But this means it will give you regular solutions like we've already had from factoring. It will also give you roots and complex numbers if your equation does not factor. So we can get all types of things out of here. So the best thing to do is just jump in and see it work. Okay. So here we have, and we're going to solve this one using the quadratic formula, is the equation 2x squared plus 5x plus 2 equals 0. So this is already in the best form we can get. So let's see, everything's on one side. So a equals 2, b equals 5, and c equals 2. So we're going to plug that into the formula. Well, let me go back to blue here. So it's x equals negative b, so that's negative 5 plus or minus the square root of b squared, so that's 5 squared, minus 4 times a times c, so that's 4 times 2 times 2. And all of that is over 2a, which is 2 times 2. So a little bit of cleanup here, just step by step, and we'll take more than we need, but we've got negative 5 plus or minus 25 minus 16 over 4. Still up top, negative 5 plus or minus square root of 9 over 4. So I'm just combining like terms. I'm really doing what's under that root first. So then I've still got my solutions being negative 5 plus or minus 3 over 4. So I took the square root of 9 to be 3, which doesn't always happen. You don't always have to have something that will work out nice. But now that everything is gone and we just got two numbers added or subtracted up top, let's separate it into two pieces since there are just real numbers. We'll have negative 5 plus 3 over 4, which is going to take us to one of our solutions, and the other one is going to come from negative 5 minus 3 over 4. So we took that plus or minus in between the two top parts, and we separated it and used it in both effects here. So let's see here. The top will give me negative 2 over 4, which is negative 1/2. That's one of the solutions. And the bottom gives me negative 8 over 4, which is negative 2. That's going to be the other solution. So the fact that I got two nice fractions out of this as answers means I probably could have factored the thing to start with. So you could go back and try it factoring if you like, but these should be the solutions. Okay? You got to get used to this formula. So let's see. Let's do another example. Alright, here's another one. It's 8x squared plus 7x minus 15 equals negative 7. This is not good because that is not set equal to 0. So we're going to add 7 to both sides, and it will look like 8x squared plus 7x minus 8 equals 0 if I add 7 to both sides? Yes. Where, in this case, a is 8, b is 7, and c is negative 8. So if there's a sign with the number, it needs to be part of that assignment, okay? So let's see what we can do here. We're going to fill everything in. Okay, x equals negative b, so negative 7. Okay, plus or minus square root of 7 squared minus 4 times 8 times negative 8. So that's 4ac, and all of that is over 2a, or 2 times 2. So let's see if I can do anything with colors here. So b was 7, so b is here, b is here. I'm highlighting them to go together. So a was this 8, which is here, and ooh, I messed up the bottom, so let me fix that. Hopefully you caught that. I'm a little excited and trying to get this right. I have no idea why I wrote 2, but that should be 2 times 8 on the bottom. So let's go back and highlight that. So that is my A's. And then my C only shows up once in the top, but that's where he comes from. So hopefully if you can see the colors, you can tell where everything comes from. Okay. So now let's go ahead and clean this up some. So negative 7 plus or minus the square root of 49. Now I've got minus minus in the second part. I got minus 4 times 8 times negative 8. So the two negatives will cancel out and give me a plus. So that might be good, but let me see what we've got here. Get to my calculator, and 8 times 8 times 4, I get 256 there. Okay, and on the bottom I have 16. So one more cleanup step as before we can do anything else, but we'll have negative 7 plus or minus the square root of, it looks like 305, all over 16. So that's not very neat the way I have it written. But let me write it one more time and try and do a little bit neater with the room that I have. Negative 7 plus or minus square root of 305 over 16. And this is two answers. You could go to your calculator and estimate this. I don't want you to just give me an estimation, but I will go in and go ahead and figure this out if I can. So if I want the square root here, 305 square root, and then I could do plus, excuse me. Hold on. I'm sorry, I was trying to use the calculator on my phone because it was handy, but I'm not so used to doing that. But if I wanted to figure out what these numbers actually look like, I could use an approximation. So by putting those in the calculator, one of them looks about like 0.654, and the other one looks about like negative 1.529. So a good exercise on using your calculator to see if you can get those. If we had an application problem, it would be good to see how big those numbers actually are. But the root solution is the exact solution, and this is the one you would really want. Also, when we see a square root or any type of root, we like to reduce it. In this case, 305 does not actually break down into anything interesting. I believe if you try and break 305 down, you get 5, and let's see, 305 divided by 5 gives me 61. And does 61 have any factors? I can't think of any right now. Yeah, I can't think of any right now. Anyway, there's nothing to pull out of 305 to reduce it, so there's no better way to write the exactness of the solution than this -7 plus or minus square root of 305 all over 16. Okay, let's try and squeeze in one more example. Here we've got 10x squared plus 9 equals x. So let's try and pull everything over to one side to start with, because that's what we need to do. So 10x squared minus x plus 9 equals 0. So we can identify our ABC. A equals 10, B equals -1, C equals 9. And let's plug those into our formula. X equals -b, which is -1, -1. Square root of b squared minus 4ac all over 2a. So let's go back like we did the last time. A was 10, so we'll highlight the 10s that ended up under the square root in the denominator. B was -1. So that was one of the leading terms and also under the root, and C was 9, which ended up under the square root only. So there's where all the terms come from. So clean this up. -1 is a positive 1, plus or minus -1 squared is a positive 1 as well. Minus 4 times 10 times 9, I believe that's minus 360, all under the root, and that's all over 20. So when I clean this up just a little bit, I've got 1 plus or minus 1 minus 360 is negative. So that's going to be fun, but it's negative 359, and that's all over 20. So we know that we can't leave a negative under the root, so we're going to have to pull that out as I. 359, square root of 359, we'll put the I on the outside, all over 20. And I'm not sure if 359 breaks down at all. Let's see here. So 359 divided by, does it divide by 3? No. 359, does it divide by 9? Well, if it doesn't divide by 3, it's not going to divide by 9. 359 divided by 11. 359 divided by 13. 359 divided by 17. I think we're quite close to being at the end of our possibilities. I'm just throwing it in the calculator here. Yes. So I did not find anything. I didn't try 7. 359 divided by 7. Yeah. So 359 has no factors that I can tell. So this is the way we would leave this. And very important to realize this is an imaginary number. So in the terms of the problem we were given, the quadratic, we have a solution. And we could actually plug that in. It's no fun at all, I can guarantee you that. But we could plug it in where we plug in that number for x up top. And we have the ways to multiply i's together and multiply roots together. So we can square things and we can combine them. It's delicate. But if this was an application problem, like how far did you drive or how high in the air is something, imaginary numbers do not give you good solutions for that. But it is a solution to the quadratics, and make sure you understand that. There'll be some practice problems.